All right, so this is lesson 4.1b. In this lesson, we are finding domain and range of reciprocal functions. Your warm-up is right here. Sketch a graph of this reciprocal function and also identify the transformations and the asymptotes. So before we get going, I'll go ahead and do the transformations and asymptotes. So this -4 shifts our graph to the right 4. And this +1, try to make it not as blurry. Oh, there we go. That's a little better. This +1 is up 1. And we have a negative sign right here, which means we're going to do an x-axis reflection. So let's go ahead and do our graph. So I need to shift right 4 and up 1. So my graph is now going to be centered here. And I also have an x-axis reflection. So if, excuse me, if you recall yesterday, we had our table for the parent function. So I'm going to use that table. I'm just going to copy it here real quick. Adjust the camera here. So we've got X's and Y's. And I've been saying that I strongly recommend you work on getting this table memorized, because then it will just make your life a lot easier. So this is going to be -1/2, -1, and -2. I don't know if you noticed, but these three are kind of a mirror image of each other. So -2s and -1/2s and the ones match. 0 is undefined. And then we have 2, 1, and 1/2. Again, opposite order as the left side. So because we have this x-axis reflection, we have to multiply all of our y's by -1. So this is going to become +1/2, +1, +2, -2, -1, and -1/2. So let's go ahead and plot those points over on our graph. So I always start with the positive. So we're going to go right 1/2, down 2. So from here, we have to kind of guesstimate these. Okay. So right 1/2, down 2. So I'm going to say right there. Right 1, down 1. And right 2, down 1/2. So that side looks like that. Then on the other side, we've got left 1/2, up 2. So let me put these here. So left 1/2, up 2. Left 1, up 1. Left 3, up 1/2. Got a little crazy there. Tried not to touch the asymptote. I just did, but we'll let it go. So the asymptotes for this one, we've got y equals 1. That's the horizontal asymptote. And we've got x equals 4, the vertical asymptote. Okay, I think I have done everything that's asked of me. So in this lesson, we are talking domain and range. So it's going to be a lot of repeat from the last lesson, and we're adding in there the piece of domain and range. So there is a pattern for the domain and the range. First of all, let's go ahead and kind of review what those mean. So the domain is the set of all x values, and the range is the set of all y values. So looking at this example here, if I'm looking at all my x values, I'm going to go ahead and take a ruler and kind of use that to guide us. So we're going to look at what values of our x-axis have a graph basically above it or below it. So if I go all the way over here to the -8, this arrow right here, the top one, that is part of my graph. So as I continue, I've got graph, 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 until I get to this asymptote right here. So my graph kind of like shoots up as soon as we get to this dotted line here. And so this dotted line does not have a value on the x-axis. But then on the other side of that dotted line, I do have a value on the x-axis, and it continues on forever to the right. So our domain goes from -infinity until we get to this asymptote, and then picks up again on the other side of the asymptote and goes towards +infinity. So the pattern that you're going to use for your domain is you're going to have -infinity until the horizontal, or excuse me, the vertical asymptote. And then it's going to pick up again. So we're going to use the union symbol, the U, and it's going to continue from that vertical asymptote on to +infinity. So when you are asked what the domain is, you're going to fill in this pattern, but you are just going to put whatever the vertical asymptote is here. So for example, on this warm-up, our vertical asymptote was 4, so I would put 4s right here. So let's go ahead and fill in our domain for this graph. So this graph, the vertical asymptote is at -1. So my domain is going to have -infinity to -1 union -1 to +infinity. So this asymptote right here is the boundary for that. So now we're going to do something similar with the y values. So the y values start, I'm going to go up my y-axis here. So starting way down here, I do have a part of my graph, and I'm kind of looking side to side. I still am going over my graph. There's graph, graph, graph. But then the graph kind of stops here, like it tapers off here and stops on that asymptote. But then it picks up again up above it and continues on to +infinity. So this horizontal asymptote is what interrupts my range. So my horizontal asymptote is going to be the interrupter, just like the vertical one was here. So we're going to have a -infinity to the horizontal asymptote, union, and then pick up again at the horizontal asymptote onto +infinity. So this horizontal asymptote is 2. So the range of this graph is -infinity to 2 and 2 to +infinity. Now, one thing you might notice is that the numbers for the Hasse and the VASI are the same numbers we have here for domain and range. So you're going to start to see some of those patterns, which is great. All right, so now let's go ahead and do our examples. So we are given 2 equations, and we're supposed to identify all transformations. Align these things. So we need transformations, asymptotes, and domain and range. Okay, so we've got to list 3 different features of the graph. So looking at this equation here, I believe we have a stretch of 3. And we're going left 2. So I'm going to go ahead and do a vertical asymptote, 2 spaces left of the y-axis. So that makes my horizontal asymptote still here on my x-axis. So that's the equation y = 0. And my vertical asymptote is at x = -2. So I'm going to go ahead and graph it, and then we'll figure out domain and range. So this one has a stretch of 3. So just like with our warm up, we're going to multiply all the y values of our parent function by 3. So our parent function is, I'm going to copy this. I'm literally just copying from the page next to this page. One thing I've been talking about in class is trying to memorize this table, but I've also been talking about shortcuts. So the x values of this table are always going to stay the same. They will always be these 7 numbers. So really, when there's a stretch, what we really care about is how did the y's change? So it's not going to be a bad idea just to write the y's down. As a matter of fact, let me show you my answer key here. So this is yesterday's homework, but I just write down my new y's. Like I have to multiply by 3 on this one. So I just wrote down all my new y values. I didn't bother writing my x values down. So that's something you could do if you're looking to do less writing. But for today, I'm going to go ahead and write it all down just to make sure you understand it. So we got -1/2, -1, -2, undefined, and then 2, 1, 1/2. So for this problem, I have to multiply all my y's by 3. So -1/2 times 3 is -1.5. And then we've got -3, -6, still undefined, and then 6, 3, and 1.5. So now I've got all the points that I need to plot. So let's see, over 1/2, up 6. So right 1/2, up 6. Right 1, up 3. Oh, this is way further over than a half. Let me try that again. There we go. And right 2, up 1.5. Just thinking about this backwards. There we go. Right 2, up 1.5. All right. So these 3 points, I don't feel like are very well representative of the shape of the graph. Like we know that these graphs curve all the way around. So I could continue like with 3, 4, or 5 to get some more points. But because I have experience with these graphs now and I know the shape of a reciprocal function, I am going to just make an educated estimation of what the rest of the graph looks like. I know these graphs curve around that corner. Okay, now we're going to do the left side. So we're going left 1/2 down 6, left 1 down 3, left 2 down 1.5. So same situation here. That one's a little angular. There we go. So our domain x values, right? So we're going to follow along the x-axis. So we have values for our graph all the way up until that asymptote where there's nothing. And then it picks up again on the other side of that. So it's -infinity until -2, union, and then -2 on to infinity. My range starts at -infinity because we have arrow down, and it goes on and on and on until my x-axis. Then it picks up again on the top. So this is -infinity to 0, and then 0 to infinity. So you have to put this union now. That's something you could lose points for on a test if you don't have it. Okay, so now let's go ahead and move on to example 2. So example 2, and in class what I did was I had everybody try this on their own and then check their answer with me. So if you would like to pause the video now and try it, go ahead. Hit play when you're ready to see the answer. So this is right 1, up 2. And so my horizontal asymptote, let's see, I had to go up 2 So that changes my horizontal asymptote. So that one's going to be at y equals 2. And then right one, that's my vertical asymptote, x equals 1. All right, so there's no stretch or compress on this one, so I can just graph my regular parent graph. I'm not going to write the table down this time. We've written the table. We have it up above. We have it on the other page. We have it on example 1. So you can always just look at somewhere where you wrote it down and use that as a reference. So I'm going to go over 1/2 up 2, over 1 up 1, over 2 up 1/2. Missed some of my points. I'm going to redraw that. I'm not happy with that one. 2, 2, 2. Okay. So 1, 1, 1/2, 2. Let's try this again. There we go. That's better. And so now we've got over 1/2 down 2, over 1 down 1, over 2 down 1/2. There we go. So the domain is interrupted by my vertical asymptote, which is at 1. And my range is interrupted by my horizontal asymptote, which is at 2. There we are. So that is domain and range. So I mentioned that we're going to be adding one new element to these graphs a day, but actually before we head into the next element, we have to do some review on factoring and stuff. So the next couple lessons are going to be factoring and then back to graphing. So looking forward to that.